Welcome to the Hamfest, everybody. Hope everybody's having a good time. Hopefully it will hold off raining. I know it's sprinkling a little bit, but we can all handle a little bit of sprinkling as long as it doesn't pour. I'm the new moderator this year, Mark WB0IQK. We still have Evan, K9SQG. He's going to be doing a presentation, and Ron, WB4HFN. We're going to start off. I might as well throw the right slides up if I figure out how to use this. There we go. There's our committee. At the end, depending on how many minutes we can squeeze out, we're going to have maybe 15, 20 minutes, questions and answers, help with troubleshooting questions, anything that comes to mind. If you can hold your questions off until the end of all these presentations, that'd be great. You know, if you're gonna forget, like a lot of us do as we age, maybe get a couple quick ones in after each person is done with their part of the presentation. Gonna start off doing just a little bit of trivia I thought might be kind of neat. Get into Ron's TR7 troubleshooting, and also the X-Lock VFO stabilizer. There's been a lot of questions about how to stabilize a TR7, so the X-Lock is one option if you don't want to get into the VFO and the carrier oscillators and stuff and try and stable them down. And then Evan will be doing how I almost lost his Drake station. And he's going to go over that. It has to do with RFI or RF. For you guys, how many people in here, let's say, are just getting into Drakes or maybe only been into it for a year or so? Show of hands. So there's been quite a few. So if you guys don't know about it, there's a nice book, The Family Affair, that John KB9AT published way back in the 1999 time frame. Great book, 300 and some pages going over the history of Drake, how they got started, through all of the different models of the radios, and there's some troubleshooting sections at the back of it. Really a good read. It's something that you can pull out every other year or so and just start all over again. Oh, I have down here 2001. So 1999, 2000, whenever. Oh, it was 2001 because I got it as the copyright off the front of the book. Yeah, and so does.
You can buy that book on Amazon.
Yeah, Amazon or Universal Radio. So Amazon might be a little bit easier for the guys out of state. So anyway, let's start out with some trivia here. Does anybody know when the RL Drake Company was started? What year? Well, well, let's see. I don't even know here. 1943. Jeff. Okay. What does the RL in Drake stand for? Robert L. Drake. Okay. Drake started out in what Ohio town? Miamisburg, right. Okay, where did they end up? What was the last location? Franklin, right. Franklin, is that in Dayton proper?
No, it's south.
Just south. Okay. I know where Miamisburg. I didn't know where Oh, I guess I go by it all the time going down to the motel. Okay, the Drake 1A receiver was the company's first receiver, meant specifically for radio amateurs, and was introduced in what year? 1958, 1957, close. Those are nice receivers too. I had one for a while. Let's see, what do we got here? What year was the Drake antique tube net started on 3865? Any answers? 1994 by Danny Schrader, WA4SDE, and Jeff Weinberg, W8CQ. Jeff is, in fact, right out at the bottom of the ramp there for you. Any of you guys want to buy anything from Harbach Electronics, he's got some nice boards for L4Bs, L7s, and other things. And also Mike Bryce, if you want to rebuild your AC4s, Mike's out in space.
I forget, but also Harbach is out there.
Yeah, well, that's Jeff.
Solid guy way in the back.
Yep.
Casey's Hamvention.
But anyway, both those guys are out in the Hamfest. Okay, the 40-meter Drake technical net was started in what year?
99.
Jeff, you're cheating. 1999 by John and Jeff. Okay, the first Drake Dayton Forum was held in what year? This forum. Does anybody know? 1998. To me, it seems like it's longer. Evan,
It was earlier than that.
well, that's what.
Spillman and you guys had.
Yeah, and I asked Danny.
Did you ask Danny Shree? How about
Yes.
Jeff Harbach?
Yep, Danny said it was 1998, so I had to go with them. I couldn't get a hold of anybody else, so I thought it would have been earlier than that, but. And I know Evan and I have been doing it for, this is the 11th year, right? So all time flies when you're having fun. Let's see here. Yep, it was started by WB8NS, and that's Don Spillman. And I couldn't get a hold of Don, so, and then Danny. So we've been on 18 years now. Why did Drake refuse to sell R4C front panels unless you turned in the old one? Somebody said something about a B.
So you wouldn't sell a 4B as a 4C.
Okay, the stated reason from Drake was so that people wouldn't take them and put them in the R4B and sell them as an R4C, basically. But then the point comes up, what about TR7s? Okay, why did Drake willingly sell TR7A insert strips without exchanging the front or the old strip? The strip, you just pull it out and then you put like a TR7 strip in there, and basically most of us wouldn't know. The answer? Who knows? We don't know.
Want me to tell you?
Well, go ahead.
Drake started to sell those strips after they were going to go out of business. As a matter of fact, when they were going out of business, they opened up and started selling every part they had.
That's at the very end, but you could still order that as soon as the TR7As came out. You could still order those strips.
Right.
That was well before they went out.
They didn't start selling them, just off the cuff until they were going out of business. And what they ended up doing, they published on their website a list.
Oh yeah.
Every
Yep.
part that they were selling. That one was on there because at that time I bought a few of those.
But you could buy them before that. That's the question. Why would they sell it to people without?
I didn't think they weren't selling them except on an exchange basis up until they announced that they were going out of business.
Okay. Who could remember this many years into it? Let's go over some quick resources. For you guys who don't know about the Drake Technical Net, we're still holding that every Sunday. We went from GMT though to Eastern Standard Time to get away from that broadcast interference we've been getting. And so far that's been working out pretty good. There's a time in the fall where we still have to put up with the broadcast for 2 or 3 weeks before they switch times, but in general that's worked out a lot better for the guys out on the East Coast. A Drake and Antique Tube Net that Evan and I run, that's on 3865 at 8 p.m. Eastern Time. Let's see, the Drake West Coast Net for you guys out in that territory, 3895 at 8 p.m. Pacific Time. And then here is the Family Affair book that John wrote. Okay, Ron, you're next.
Here you do it.
That's okay.
Had you worried, didn't I? Well, as everybody knows, I'm WB4HFN. I gotta look at my name tag, make sure the name's right. We're gonna talk a little bit about TR7 today. We're gonna talk about a little bit of history.
They're real loud next door here.
How about if I just talk up? How's that? Everybody hear me now?
That's your normal voice level.
Yeah, I know. We're talking about common easy to fix problems, little troubleshooting, some modifications, talk a little bit about the X-Lock, and Mark said hold questions to the end, okay? Yeah. Next slide.
What's going on here, guys? Well, that's nice. Let me use.
What'd you do? Forget how to punch a
No,
button?
it's
Let's
try it out.
All right. First of all, let's talk about the great TR7 and the SB104. What do they have in common? Anybody know what they have in common? What's that?
Designer.
Designer. Go ahead, flip it. Mike Elliott started out and went to work for Heathkit to design an all-solid-state radio. Heathkit told him he had to design it using the parts that they normally stock. He didn't like that. But he designed the SB104 that Bob Drake hired him, and he basically designed the TR7. But Bob Drake told him, you design it the way you want it. Which is why he used, for instance, a 48.05 IF and high IF, which really gives the radio its selectivity. So anyway, next, easy to fix problems. You have my little service tech here, okay? All right, the first one, in case you don't know, there is a 5 amp internal fuse. This is the mode frequency set board. This is the back side of the DR7 display board. It's tucked right here in the corner. You have to stand on your head to get it out. But what I usually do is take a pair of tweezers and grab it on the end, pull it out, pull it up, and then put one back in the same way. It takes a few seconds to do. A lot of people take out the DR7 board and all like that to get to it, but a pair of needle nose pliers, just grab it here, pull it this way, then pull it out, and then put it back in the same way. It usually works pretty quick. Okay? I'm not going to read all this because this presentation and the entire presentation will both be on my website as of Sunday. And you can, it'll be in a PDF format. You can download it and read all about it. Okay, if your display all of a sudden is randomly counting upwards, if it counts up to 17 megahertz and kind of stops, that means your band switch is on 20 meters down to 160. If it counts up to about 32 megahertz and it's on 10 or 15 meters. There are two VCOs inside the TR7, a 32 megahertz and a 17 megahertz, and the VCO is not locking, so it goes all the way up to the top of its range, and the counter will just sit there and run around in that general frequency area. A very common problem on the power supply board down at the bottom, there's a little transformer right here. It's a 24 volt multivibrator. It's taking 12 volts, multiplying it up to 24 volts. If this little transformer comes loose, the voltage drops down to 22, 2120. The upper VCO, especially the 32 megahertz VCO, must have a full 24 volts to lock. Okay, next slide. No, go back one.
Go back one. Okay.
There you go. What happens, you'll notice that the little transformer would come apart. They must be fully meshed together. The core must be meshed together for that multivibrator to put out the proper voltage. A lot of times it's tied together with a piece of wire. They'll work loose. In such case here, and once it breaks loose, it pulls out like this real easy. What I have been doing and I found works perfectly is I put a little drop of super glue on each end, not the center, each end. Mash them together, let it adhere, and and they will never come apart again. I have been doing that for years, and it does not affect the vibrator or the voltage in the output. Just don't put it in the center. Okay, next. All right, now we're going to talk about what kind of boards are in here. This is the DR7 board. Everything is controlled for the display of this board. This section here is the VCO lock. And this is, the VCO lock is here. This side of the board is nothing more than a display. It takes the VCO lock frequency, divides it by 48.05, and displays the resulting frequency. As you'll notice on my upgrade TR7, which I'll get to in a minute, most of the board is cut out. The DR7 board is actually locked out. I've cut out the part that is required for the VCO to lock. But this whole display has now been replaced by a different display. We might want to plug that in, Mark, at some point, I guess. But I'll get to that in a minute. Okay.
Can you handle that, Mark?
Oh, the problem is I can't do the slide here.
Yeah,
Go ahead.
next one. All right, the next one, these are your various boards. For troubleshooting, you've got your low pass filter for the output and the high pass filter. This one is your input. This one is basically the power output from the amplifier goes this way. The input goes through this one and this one to the up converter here. If your upper sideband or your lower sideband sounds funny, these adjustments here are the mode frequency adjustments, the fine-tuning mode frequency adjustments to get it dead on, and I'll be touching on that in just a few seconds. Other than that, here's a list of all the boards. Common problems that I found out, if the VCO doesn't want to lock, a lot of times it's a dirty connector up through here. The boards, all these boards in through here and up through here inherently have a tendency to wiggle their way out of the motherboard. If you shift it or you jostle it around a lot and all of a sudden something isn't working, go in through here and push all these boards down tight against the motherboard. That will fix a lot of the problems. Other common problems in the IF board, you've got your IF select pushed in where there's no filter. This is the reference board here. A lot of times your reference oscillator is off. It should be exactly 40.0 megahertz. The IF audio board, there's some problems back here when you're adjusting your RF power out. That attenuator is in this circuit. The PTO itself, if it's still got the original grease in it, you're going to find that the gears are starting to stick. Grease gets in between the frequency dials and they won't turn. It starts to skip. This little lever right here, that's a spring-loaded lever, that goes between the two, you'll find out that kind of gets frozen. And if you turn it and it pops back, next thing you know, your analog dials are all over the place. Very common problem. That needs to be cleaned out pretty good. Other than that, clean the controls, clean the switches with a good contact cleaner. The PA itself rarely goes bad, but sometimes the finals can go bad. They're easily replaceable. RF Parts sells the finals. They used to be about $50 each. I think now, Jeff, the last time they went up to about $100 a piece now.
Yeah, they're pretty expensive.
Yeah,
The original
right.
type, Motorola, you mean the Motorola ones? Or?
Yeah.
Yeah.
I think they're
If you can get an
about
MRF
$100, so
421.
it's about $200 for the man.
For the MRF 421,
So
yeah.
they've almost doubled their price in the last, what, 6 months or so, Jeff?
At least.
Yeah, okay. Okay, let's go with the next slide. A lot of times, again, if you got normal power out of 160 to 40, then you notice there's a little power lower on 20. 10 meters and 15 meters, you hardly get any power ground at all. That pin diode, you heard about the pin diodes. These are the two pin diodes that passes and turns off the calibrator signal. Usually this first one right here shorts out. The minute it shorts out, it drains the high, the 10 and 15 meter RF power down to about nothing. And what it's doing, it's on the output, it's in the driver stage. It's coming out of the mixer board, goes into the input, the high pass input, where this is. So it's killing 200 millivolts of signal, shorting it to ground. But it seems to have much more effect the higher you go in frequency. And these, again, it's a, what is that, 1N3404?
MPN
NPN 3404.
They're cheap. They're real, replace both of them, really.
Yeah, you want to replace both of them. But it's usually the first one that shorts. This one will end up eventually leaking. But you can get those from RF Parts, and I think they're, what, about
Cheap.
$1 a piece or something?
I think you can get them cheaper even in the flea market.
Yeah. Yeah, they're readily available. Okay, next slide. All right, this is on the other end of the high-pass filter. There are 3 pin diodes here. Now, these are high current because this is switching RF. So they are a little bit more. Generally speaking, one of these 3, usually this one, will be a dead short when it goes bad. So they check like a normal diode. It has a forward and reverse resistance. It's about 100 to 1 or so. But usually that one shorts is the main problem with that. Okay, and again, this is on the high pass board, the rear section of the high pass board. Okay. Okay, internal adjustments. Just don't let the hand come out of the computer and gouge your nose. All right. This is the frequency, the mode frequency adjustments. So once you've set the master oscillator, you've also set the passband tuning frequency. Then you can go in and adjust these individually. First thing, make sure that's on 10 volts, because if you move that as much as a tenth of a volt, it's going to throw the master oscillator off frequency. It's also going to pull the other oscillator off frequency, and you're up a creek.
After a good warm-up.
What's that?
After a good warm-up.
After a good warm-up, of course. Absolutely. But set this point for 10.0 volts before you make any adjustments. And you will even set this 10.0 volts before you make any alignment or any other adjustments to the radio. This is the first thing you want to make sure is dead on. 10 volts. And you can test any one of these contacts on top of any of those resistors. You can use as a test point for 10 volts. Not that one, but these other 5. And then once you have that set, this is like for AM, ready, CW, lower sideband and upper sideband. You adjust those individually for the mode frequency. We'll show you a trick on how to do that on the next slide.
What about cleaning the pots before you make the adjustment?
Yeah, just a light contact cleaner. Just put just a little bit. Twist it on both sides. Get it kind of cleaned out. Deoxit. Have you used deoxit on that? On those?
Yeah, but I do blow them out after a while. Like, don't keep it in there.
Yeah, accidentally. You never want to leave deoxit. You always want to clean that out.
Blow it out.
Yeah, blow it out.
Talk to them.
What's that?
You're talking to me, talk to them so they can hear you.
Okay. All right.
You like?
I've been sitting in front of radios too long. All right, next slide.
Next one, Mark.
This is it.
It is?
Yeah, that's the one we were
All
on.
right. Yeah, all right. Go to the next one. There you go. The easy way to adjust it, put your radio on 20 meters. Make sure all the other alignments done, your master oscillator and everything is all set. Put it on 20 meters. Drop it down so that it'll in a range of 13.5 to 14.0. Put your mode switch to AM and you adjust
You peak the meter in AM position for 13.695. Or tuned for maximum signal, it should be 13.695. That's dead on frequency. The same thing, ready. You tune it to 13.697. Now you've got the BFO running. Use 0B. CW 13.694.2 and 0B the CW control. And I also found out if you put it in AM, if you have an AM filter, or you have the AM mod, resistor mod, which I'll show you in a minute, put it in AM, and you can 0-beat it easier because it'll go to 0 and then back up. If you have one of the sideband filters selected, it'll go to 0, but you won't hear it go back up because it's now on the other sideband. So I always put the AM mod in it and adjust it with the wideband filter so I can hear it go to 0 and then back up. Then I know I have it 0-beat it. Same thing, upper sideband 13.696.4, lower sideband 13.693.6. And that's something that I don't, was that ever published by Drake?
No, you really want to make sure your 805 oscillator's on also.
Right, oh yeah.
Right. 805, that's correct.
There's 3 oscillators in there that you need to set, which I've gone through in this presentation. Okay, next slide. Okay, if you want to set your 40 megahertz signal, I usually just do it right here. Now Drake tells you to come back here and tune it back here, but it's a very low level signal, and it's not enough for frequency counters or whatever to read it. But there's plenty of signal here. And Drake said that it will pull it off frequency just a little bit. I have really not found that to be the case. So I set it here at this test point, and you'll find the coax cable that's coming out here, center pin, and a frequency counter right here. But you have to use a high impedance probe. You use anything that loads down the circuit, it will change the frequency. So you don't want to load the circuit down. And then the adjustment for it is on the reference board, and it's the second coil from the edge. Adjust it right here. If you want to adjust the 5305, it's right in here. And then this capacitor right here is using to adjust the 500 kilohertz signal. The 500 kilohertz signal is this last trace over in this corner. Again, high impedance. Do not load the circuit down or you will change the frequency.
Ron, could you move over to the right a little bit?
To the right.
There you go. Great, thank you.
What's the matter? You can't see through my skinny body? Okay, next slide. Okay, you want to set the power output. R201, this sets the forward power output. What I usually do is if I have a bird, I'll set it to 100 watts on a bird element. Then I'll adjust this control for 100 watts on the meter. The reverse is set up a little differently. To set this control, you pull the antenna loose, you key the transmitter. Assuming the TR7 is working fine, the higher SWR will shut down the power supply to the point that you're getting 15 or 20 watts out. On the power meter switch, you push it out. Whenever the forward power is registering, usually it'll go up 2 or 3, you put the switch in reverse, and you adjust this control so that when you push the power, the watt meter switch in and out, this now matches the forward power, and that's how you calibrate.
Foolproof.
What's that?
It's foolproof.
Okay, setting the RTT, the RIT, there's a little adjustment back here. And you push the RIT in and out, put your RIT straight up, and you adjust this switch so that whatever beat frequency you've got, when you push it in, push it out, is identically the same. Then you've got your RIT centered on the front of the radio. Okay. Quick and easy mods. All right, the AM mod that I was talking about before, there is the first IF filter in there is 8 megahertz wide. If you put a resistor across where the filter would normally go, this will give you 8 kilohertz wide IF, and it's pretty good broadcast. This one is showing a 470 ohm resistor. I think the instructions were like anything from 150 up to not over about this value will work. And I use a 2-watt resistor because the 2-watt resistor is the same size as the pin on here, and you can just bend it over. Some people say put a small capacitor from here to ground. I don't normally do that, but if you want to put a capacitor across it to put it in there, it will probably help cut off some of the higher edges. Okay, and this just shows it to you a little bit up close. Your normal filter would fit in right here, and you just solder in this one in this case is a 470, but you can, I think more common is 150 ohm resistor, but a 2-watt resistor, any low value resistor will work. The higher the resistor, of course, it's going to attenuate the signal a little bit, but even 470, it's not even noticeable. Okay. For those people who want to open up the Drake TR7 so you can eliminate the need for the aux7 board for being able to transmit all of the other frequency outside the 5 or 6 main bands that it's designed for. This is the front right corner when the radio is turned upside down. Your aux7 plugs in here. There's a little trace right here. Just break that trace open, and that will open up the transmitter to operate. You can transmit on any frequency from about 1.5 megahertz to 30 megahertz. In other words, wherever you put the receiver, the transmitter will work. That's all you do is cut that one trace. Yeah, just cut that trace. You can use an X-Acto tool, you can use a sharp knife, whatever. Just break that one trace open. But I'm also going to say, in the work bands, make sure you know what frequency you're on. Keep it legal. We don't want to help the CBers or anybody else that wants to operate illegally. All right, and remember this. That's right. The TR7 is not type accepted if anybody asks. Okay. This is the X-Lock board. You have to just, the company is in England. You have to place your order online, and you'll get it in about 2 weeks. Keep in mind, it looks like it's $32, but there's an L in front of it, or it's British pounds. I fell for that the first time. I thought they overcharged me. But it's British pounds. It's rated in British pounds, but US dollars is about $50, $52 each. But yes, it's a kit. You get a board, you have to plug in all the parts and solder, and there is some tedious soldering there, small point. So if you don't have the proper soldering tool to do fine work, you might want to get somebody else to put it together. Go back. Okay, well this is how it looks. And this is the X-Lock installed into a TR7. Once it's in the TR7, this depends upon where you set the sampling rate. This will detect a 25 hertz variance. If it drifts more than 25 hertz, this X-Lock will send out a voltage to readjust it. So basically, I have found out that this thing will vary 25 cycles from dead cold to 3 hours later when it's nice and warm. It does not drift if it's installed properly. Now this, since the bottom pan fits over us, you don't have much room. So I mounted a terminal strip horizontally, and I hooked it onto one screw here, and I put double-sided tape under it to hold it in place, and then ran the wiring around. Now I'm not going to go into how the wiring goes, But basically it takes 12 volts and it produces a voltage which ties to the RIT. And the RIT and this voltage works in parallel to keep everything dead on frequency. I'm not going to go into the particulars because on my website now there are two articles written by two different authors on the installation of this. And it's fairly easy to do. And each one of them has a set of instructions on, step-by-step instructions on how to do it and how to install it. Both of them are different, so read them both and choose the best one for you. Yes, sir.
What is the URL for your website?
What's that?
What's the URL?
It's right here.
There.
Oh,
It's on the slide.
wb4hfn.com. All right, on the X-Lock board, there are two programming buttons. One is used to set the sampling rate, and the other one is used to set a delay between the time you turn the knob to when it starts to sample a rate. Usually it's a few I think they said, what is it, Jeff? Set to what, 10 milliseconds?
Oh, I don't know. I haven't
Okay.
done that. No, I haven't done that.
I've installed several of these, and they seem to work very well. I'm very pleased with it. They asked me, can you put it into a tube radio? Yes. All that you have to have, the PTO has a voltage input to slightly adjust it, whether it's ever used or not. They were all made with that particular notch there. The only thing is you have to have a 12-volt supply, well filtered, and sometimes I can mount it right on top of the PTO. So it is possible, but it's a little more work. But yes, it's possible. Okay. The other thing I'm going to talk about, you remember last year I brought this radio.
Want me to hold it up?
Well, it's going to be up here to see. Yeah.
What if I drop it, Ron?
That's right, I have another one. Last year I put in the display, the new display, and put in the 110 volt power supply. Next slide. And I said, this is what I did. I put in an AC power supply, put in the blue filters. I cut out all the display board that I didn't need, removed all of the analog dials, new LED backgrounds, transmit pre-driver, noise, new diodes in the balance modulator, tunnel diodes. That's what I did last year. And I said last year, next slide, said by this time this year, I was going to add a digital VFO, a digital PTO, eliminate all of the analog, which I've done. I said that I was going to eliminate the the aux programming switch, and I was going to put in a digital signal processor, which is now done. And I can show it to you up here in the next slide. Basically what I've done here, I've got, since I no longer need the aux program switch, I converted that. So I've programmed that signal processor. I put in a 2.8 kilohertz filter, which I'll show you in a minute. But the program switch now has 5 sideband positions going from 2.8 to 1.5. And the last 3 are CW, which is about a 500, a 300, and a 200 kilohertz bandwidth. Okay. All right, this is the noise blanker board, and this is the new 2.8 filter, and I bought it off eBay. You know, there's guys selling 2.8 IF filters for the TR7 at like $29. They work, they're good. But you take the aluminum can off of it, it's nothing more than a nice little flat board. So I mounted that on the noise blanker board. So now the IF crystal filter's there, and you will be able to see that in that radio. Just look for where the noise blanker goes and you'll see how that's mounted. So that is the only IF filter I've got in the board. The signal processor takes care of the bandwidth. Okay, as you'll see, the digital display is mounted here, which was in last year. This is the new digital VFO. It produces 4.9 to 5.5 megahertz. and that is plugs directly into the VCO, and it works good. And you'll notice that on this one I have 3 lights on the front. I can select go to that. I can select VFO A, B, and then when the green light is on, you push it again, push it twice, and now I can do split. And I'll do the green light will come on, and then I hit it again, and I can toggle back and forth which VFO is for transmit, which VFO is for receive. And you'll notice that I relabeled the panel here. This is the VFO select, and then I can press this button in, and it locks the VFO. That says bandwidth selector now, and I've relabeled a lot of this stuff up here. Go back one slide.
Is that the TR7.5 run?
What's that?
TR7.5?
Actually, I'll show you in a minute what I did. By the way, this is the signal processor board. This is the AC power supply. This is a signal processor board that you'll see where the old power supply went. Okay, go to the next one. I labeled it TR7B.
Oh.
TR7B.
That's pretty good.
Okay, the radio's up here. You can look inside of it if you want to. By the way, I'm going to lay a bunch of pins out here. It's got my call sign on it. So if anybody wants a nice blue pin, I know you've already got one. If you want to, tell them yourself.
Thanks, Ron. Evan, your turn. Oh, there's the pointer. Use the right to advance.
Are you going to go into production? That's my question.
This one to advance.
Yeah, that advances.
You know,
If you got to go back. Then.
I've actually done a few of these now.
They quit making that way.
82. 1982.
Good morning. My name is Evan, K9 SQG, and I'm going to make a very brief presentation to relate to you some of the stress that I've had over recent years. And while I didn't lose all my Drakes, I lost some of them, and I didn't really lose them. I sort of gave them away, shall we say. As ham operators and Drake enthusiasts, we have some common goals here. And one of the things that's important is not to deprive others of, enjoying the hobby as much as we do. And one of the annoyances that I experience is that I have RF on my voice, and I'd contacted the manufacturer, and he said, I'm version 1.0, so what can you expect? But on the air, I had experiences with some distorted audio. And for 10 years or more, the station configuration that I had at home was working fine. I didn't have any problems with bad audio, erratic power output, or anything. And then the gremlins came and went at will. And I would turn on the rig. Sometimes everything would be fine. At other times, I'd run into problems with distortion. And everything in the shack that I could tell in terms of operational monitoring was fine. Power output, SWR, calibrated adjustments where I reset the tuners and amplifier and so forth. There was no problem at all. This is the station that I was using here, although it went through a lot of changes, if you will, as I went through this saga.
It's too neat. That's what the problem
is. Maybe. So I thought maybe changing the equipment. Maybe I was running into some problems with the TR7 or whatever. And so I tried the C-line. That didn't change anything. I had a couple of other TR7As. Didn't have any effect. I had a Kenwood 830S, which is a hybrid rather than solid state. No change. Kenwood 590S, which is a more modern radio. And even had an antique rig that I used on AM. And none of these had any effect whatsoever. So then I thought, well, maybe I've got a problem with the microphone. You can run into problems with inadequate shielding, erratic operation of push-to-talk switches, and so forth. So these are some of the changes that I went through, and absolutely no change when I was having a distortion problem. So then I thought, well, maybe I've got a problem with the linear or the tubes. So then I swapped out the linears, tried some spare L4Bs, L7s, absolutely no change at all. So then I thought, well, maybe there was a problem with an antenna tuner. Maybe some of the switch contacts were dirty. Maybe I had a bad internal ground or something like that. So I started swapping out antenna tuners, MN2000, a couple of 2700s, even a Johnson Matchbox, which I thought would solve the problem because there's no direct connection between the antenna and the transmitter, if you will. That didn't have any effect. The Night Viking MB5A, same thing. Palstar BT 1500, none of these things seemed to have any effect. So then I thought, well, maybe I'm getting RF into the power lines in some way. Maybe I've got a loose neutral connection or something like that somewhere along the power feed. AAA line conditioner didn't help. Medical grade isolation transformer, nothing. I applied ferrite beads on virtually every single cable in my ham shack. I mean, I put, I don't know, 40, 45 of those things on each end of every lead. Didn't have any effect. So then I thought, well, maybe it's actually something in the antenna. Maybe I've got a corroded connection or something. So I replaced the 40-meter loop, which is this is where I had the problem on 40 meters, not on the other bands. I replaced all the wire, all the insulators and feed line on all these antennas. Also the quick disconnects that I use for disconnecting things when we've got storms in the area. And then I also improved the ground by adding more ground rods, tied the heating duct system in, the cold water system, and so forth. No effect. So then I started replacing the jumpers in the shack between the linear and the rig and the watt meter and so on and so forth. And one of the jumpers that I had was 12 inches long, and when I took that one out and replaced it, the distortion went away. And the interesting thing is, I tested that particular jumper, and it had no leakage. I had continuity with the ground lead as well as a center conductor, no problem at all. I was a little surprised because that jumper was only 50 years old. So, but at any rate, problem solved, or so I thought. I was a happy camper, and then the gremlins returned again. And at this point, I got really frustrated because there was literally nothing else I could change. I changed everything from the microphone all the way through to the antenna, and the distortion would still come and go. So that was so frustrating because I didn't know when I would get on the air, am I going to get another report about bad distortion or something like that. Plus, I didn't want to create heartache for the people that had to listen to me. A lot of Drake enthusiasts encouraged me to stay with the hobby, but I had to deal with the facts as a scientist. So I started selling off some of the equipment that I had used with the tests here, and you can see there was quite a lot involved. I had some final key erase experiments, though I just didn't want to give up. And what I found is that as I started going through these checks here, I actually started making some improvements. The one-to-one balun at the entry improved, and then I went from basically 450 ohm feed line to coax, and that helped a little bit. I installed a feed line choke in the shack. That helped a little bit. And then I found out that disconnecting the 80-meter loop from the tuner helped significantly. And I thought, gee, that's sort of interesting. And I found out that that was basically the problem causing the distortion. So then I installed a double-pole, double-throw relay. When I'm on 40 meters, it electrically disconnects the 80-meter antenna from the shack. I also found that switching from an L7 amplifier to switching from the L4B to the L7 also improved RF in the shack, and I used a field strength meter to make these measurements. This is a picture of the installation. This is where the feed line comes into the house through the wall. This is the one-to-one choke balun there, and then I've got some heavy copper strap that goes outside to the window well casing, and a ground rod. Here's a picture in the shack. That's the balun for the 80-meter antenna, and then this is the relay that disconnects the 80-meter antenna when I'm on 40 meters. So the conclusions that I have is that I basically haven't had any reports of distortion this year, except for one case where I had my mic gain a little bit too high. I, at this point, still don't know why this distortion came and went. It started after about 10 years of operation, and then it just came and went at will, and I still have no explanation for why that happened, but I do have a cure for it. What was happening is that I was getting RF pickup from my 80-meter loop, which was concentric with the 40-meter loop. So that's not surprising. And so then the energy was conducted into the ham shack and then through the balun on the MN2700. The MN2700 balun has one lead that always goes to ground. So what I had was a ground lead from my station that went out to the backyard, and I had an antenna connected to my ground system, and that seemed to be what was causing the distortion. Oops. Did we just lose something? I'm right at the end. Okay, so here are the culprits that I had in my shack, and I'm sort of apprehensive about calling them culprits because it's really some good equipment. But the MN2700 Ballon has one of the leads in the Ballon going to ground. So one lead of your antenna is always going to the ground, if you will, of the tuner. And since I had a 80-meter loop that was concentric with the 40-meter loop, it was just too much RF getting into the ground system. The L4B amplifier, you see part of it down there, has a perforated cabinet. And I found out that by going to the L7, there's significantly less RF pickup in the shack. In other words, that perforated cabinet gives you good cooling, but by the same token, the RF energy was fairly strong in the shack. And I got something like a 10 dB improvement in RF in the shack just by going from the L4B to the L7. But again, I've never had a problem with the L4B in the past. So that's my story. I'm still keeping the Drake equipment that I have, and hopefully the distortion is gone forever.
Thanks, Evan.